So we're on number 7. It's on page 3. If that matters to you, I think you probably have it in front of you. Number 7 is a 10-pointer standalone problem about a cone-shaped tank, point down, and it's leaking at a rate of 2 cubic meters per hour. That's a pretty serious leak. Probably not very big. Initially, the tank is full of water, so that's a nice thing to know. It is 9 meters tall and 6 meters across at the top. How fast is the diameter of the surface of the water changing when the radius of the water surface is 2? It gives you a hint. It gives you a hint on the test as well, so you don't have to memorize or try to remember in detail the volume of the cone. And I will tell you that the problem on the actual final is a cone as well. May not have quite the same details that I have here, but it's a cone. Okay, and it is point down. Hallelujah. I requested that. I said, if you're going to do a related rates problem involving a cone, please make it point down. Okay, so here's our cone, and it is, according to the words, how tall? 9 meters. That's pretty tall. And it's how far across? 6, making the radius 3. Okay, and it is leaking, meaning it's losing water, which means the VDT is -2. Y'all clear what's going on here? Remember, with related rate problems, you list the things that change somewhere off the picture. I put these on the picture because they are not going to change. The VDT is something that's changing, and it's changing it at -2. And it is cubic meters per hour. You can put that on there if you want. I'm not going to calculate with it, so I'm not putting it on there. And we wish to know this eventually. We wish to know what dt is, meaning the change in the diameter per time. But I'm going to find drdt, and I'll talk about doubling it. The one thing they do give us is how fast is the diameter is changing when the radius of the water is 2. And so over here, I'm going to put r equals 2. I'll put my list of stuff. And if it's 3 up here, then I'm saying probably about right there. And this is, I'm not going to put a 2 on there because it's changing. I'm going to put an r on there. And I'm going to put an h over here because it's changing. And the reason I'm putting an h over here is because the formula, pi r squared h, or pi thirds r squared h, involves r and h. So here's what I've got. V equals pi r squared h. And I'm not ready to derive yet because I want to get this written in terms of just one variable, which requires some knowledge of similar triangles. So what I'm saying is that this r is to this h exactly the same as 3 is to 9.
Shouldn't it be pi thirds for the volume?
Sorry?
The volume, shouldn't it be
Oh, yeah.
pi thirds?
Yep. There you go. So I'm going to depend on the similar triangles over here. R is to h is 3 is to 9. Yeah. Except for I'm going to reduce the fraction. 3 is to 9, same as 1 is to 3, as r is to h. And if I cross multiply, I get h equals 3r. My question is, do I want h equals something with an r in it, or do I want r equals something with an h in it?
H with an R.
We want to replace h with something with an r in it because the problem is about the change in r, right? Okay. So that's solved the way I want it. It's going to be pi thirds, and it will be r squared, but it will, instead of h, it will be 3r. Is that okay? Now, I haven't derived yet, and I'm not going to derive yet either. I'm going to clean things up a little bit. And I didn't do this on purpose. This is just serendipity. The 3's are going to cancel here. And I'm going to end up with just pi r cubed. That's volume for this particular situation. We good? So now I'm ready to derive once I get this in terms of r, which is what I'm after, the drdt, and I'm going to clean it up, and then I'm ready to do this, and not until. dvdt is going to be 3 pi r squared drdt. Yeah? Don't forget everything's has to be derived by t, which is time. Okay, so now I'm going to say, remember, I'm trying to find drdt, and I will reconcile that with the change in the diameter in just a minute. So I have dv dt divided by 3 pi r squared, and that will be dr dt. And I like to solve for what I want to find first, and then I'm going to plug the things in. This will be negative 2 over 3 pi times 2 squared. You okay on that? Y'all see all the substitutions? Okay, and that's going to be, I can't remember what I don't have my key here. So what's the answer to this? When you get that all worked out in your calculator?
Negative 0.6 pi.
Negative what?
0.05.
0.5?
Negative 1 over 6 pi.
Oh, all right. You can write it that way, that's fine. Then what will be the rate at which the diameter is changing at that point? Pardon? Negative 1 over 3 pi. Because the diameter, see, as this thing drains, the radius is getting shorter like this. It comes down, it keeps getting shorter. So it's changing at a negative rate because it's leaking. The diameter is cutting in 2 of those lengths as it comes down. One here and one here, so we double it. Does that make sense? And what are the units on it? Meters per hour. Okay. And you can write it like that, or you can give me a decimal. Doesn't matter. I did all the talking. Y'all follow that?
How many decimal places are we gonna make go out?
Oh, it's typical 2 or 3. I'll give you, if it's correct of whatever place you decide to go with, it's fine. Just don't round, just don't be too gross with the answer. Get it, put a little detail to it. 2 or 3 places is typical. If you were taking the AP exam, it's always 3 places for everything that you round. Okay? Everybody good on this one? Okay. So that's number 7. Number 8. Consider the 2 parabolas. And when we had our discussion with the teachers at a Zoom meeting about this, several of us said, why the cruddy fraction? And the guy said, so that it would work out and the cross points, the places where it intersected would be nice and pretty. So, because he said that, I'm allowed to tell you that, on the final exam, when you find the cross points, they will be nice, neat points. I tried like crazy to come up with crazy fractions that meet in nice, neat points. I couldn't come up with any, so I just threw some crazy fractions in. So this one is going to be, I wouldn't say tougher, but not as clean as the one on your actual final, because the cross points of F and G on this, with those nasty fractions, which is what you really have to work with, is not nice. Because I made it up and I wasn't willing to make it up with ugly fractions and nice cross points.
Can we use a bunch of mid-10s to intersect?
Sorry?
Can we use a bunch of mid-10 calculated intersect?
Absolutely. This is completely, to me anyway, a complete and total calculator problem. The professor at ISU said, I really wish the kids would show their work on this. Well, that's ridiculous with those kind of fractions. And I will argue that for you if it comes to it. So I will show you how to make your calculator do all the grunt work with these nasty, nasty things. If you will just take the time to very, very carefully put F in Y1 and G in Y2. So let's do that first. Use the fractions, not some decimal, because that way you're not approximating anything. And when you're done putting it in, read it very carefully and make sure you put in what you intend, because it'll screw everything up if you don't. Every answer will be wrong. That's the one bad thing about calculators. You'll do exactly what you tell them. If you tell them wrong, you're out of luck. Okay, then I suggest you try to graph them in a standard screen and see if you want to adjust your window at all. Okay, so this is what I get. Blue is F and red is G. And I'm okay with that screen. I can see pretty well and it's pretty big. So, first one says A, which is what 4 points, calculate, which means do it however you want. I'm using a calculator. Calculate the intersection points x, y where the two parabolas intersect. I think it's fairly clear that they intersect at 0, 2, but if you want to check that out, make sure it's really 0, 2, you should, it is. And then I gotta go find the other one, so I'm gonna calculate and intersect. Get closer to that intersect point before you hit enter. So the A part on this one is 0, 2, and 6.8. I'm gonna call it that because there's 2 zeros after it, so I'm gonna say 6.8, comma, 3.61. Is that what you're getting?
Yeah.
Yep.
Okay, 4 points, just like that, to make your calculator find it. Just make sure you put in there what you intend. And I will tell you, like I said, on the final, the points are very, very nice. If you don't get really nice points, then go check and make sure you put in what you intended. This one is not, so here we go. That's the A part. B part says, determine the x values in the interval enclosed by the parabolas. In other words, find the x values between 0 and 6.8, at which the vertical distance between them is a maximum. What is the vertical distance between them?
Y2 minus Y1.
Yep, y2 minus y1. I'm going to say g of x minus f of x just to stay true to what's presented in the problem. Is that okay? But g is y1 or y2. And the difference between the y values is the big one minus the small one, which is g minus f. Where is that the biggest? What he wants you to do, the professor at ISU, wants you to actually write out g of x with all of its really super gross fractions, and this one as well, get them together, combine the like terms, and then derive it, set it equal to 0, and see if it works, because that's the calculus behind it. What I want you to do is to take y1 minus y2, y2 minus y1 in y3, turn the other two off, and find the maximum. That's not calculus, but it is showing skills with this. So we go to y1, or we go back to the where we put in y values, and then in y3, I'm going to go vars, y vars function y2 minus y1 in the vars p, and I'm going to turn the other two off, so I'm only looking at this difference. You know how to do that? Don't erase them, for heaven's sake, because it's got to have something to reference. But turn the two off, you know how to do that, right? If you turn them off and graph it, my graph on y3 is black, and it's the only one I'm seeing. It looks like that. It's the maximum of this, because this is a graph of the differences between f and g, or g and f. And it looks like that when you turn the other two off and just find the maximum of that. It's no calculus involved. It's strictly a calculator exercise, in my opinion. So max. And I get a maximum value of 8.009, so 8.01. Is that what you're getting? How does the question ask it? Does it just want the maximum value?
Just wants the x
value.
values.
Oh, just the x at where it occurs. Determine the x value in the intervals enclosed at which the vertical distance between the lines. Okay, never mind then. It's not the value, it's where it occurs. So 3.4, just 3.4.
You know, will that be a pretty number as well?
I can't remember. I wouldn't count on it.
That's not too bad.
Yeah.
It's an easy problem.
Okay, so what the y value tells you, the 8.0, just in case you're wondering, the 8.009, that tells you how far apart they are at 3.04, which is the maximum distance between them, and it's 8, I think. Okay, you good? Okay, C part says, find the area of the region enclosed by the two parabolas. The area enclosed is going to be top minus bottom. That will be the integral of g of x minus f of x from 0 to 6.8. You agree? You understand what's going on here? That'll find the area between the two. or not?
Yeah.
You good? Okay. So we go back to the home screen now, and again, exploit our Y1 and Y2. So we go back to the home screen and say math 9. And we go 0 and 6.8. Oops, let's do that. 0 and 6.8. You may want to have stored this, maybe, if it's in all of its unapproximatedness, and gone from 0 to A, if you stored it in A. I'm going to go with 6.8 because I remember it being pretty clean when I did it. On the test, it'll be clean. Okay, so 6.8. And then I'm going to go, and when you go to type it in here, you can actually just go find these again. Bars, Y bars, you don't have to type it in. Y2 minus bars, Y bars, function, Y1,
If you left it in
dx.
Y3, could you just do bars Y3 and just put
Sure,
that in
you
there?
betcha. And I should have done that. Yeah. Yep,
Wow.
absolutely.
Okay, Richard.
Okay, I see.
You've already got Y3 as Y2 minus Y1, so you can just do the integral of Y3. That's perfect. That's great. And I get 36.31. Is that what you're getting?
Yeah, what?
Okay. D part. D part wants set up but do not evaluate an integral that represents the volume of the solid obtained by rotating the region from C about the line x equals -1. If you're going to wrap it around x equals -1, which is vertical, and you're integrating from 0 to here, which is the natural way to do it, then your slices are parallel, which means we need the shell method. Okay, so each shell, if it's stretched out, looks like this. Where this is obviously dx, this is what? Y3. Isn't it? Isn't that the length of each? We good on that?
Yep.
Natalia?
Minus that with it.
Y2 minus Y1, as he pointed out, is Y3. And that's the length of each of the slices as we go out and gather those and wrap them around. This is the part that'll hang you if you don't do it right. If we're going to wrap it around the line x equals -1, we've got an additional unit on every radius. So it will be 2 pi, not x, but x plus 1.
Will it ever be like x minus 1 or is it always plus?
Like if it was around the line.
The only way it would be x minus 1 is if you were going to wrap it around the line x equals 1, because now we're 1 unit short for each radius. Do you want to see what I'm talking about?
No, yeah, I understand.
You do?
Mhm.
Okay. Then the integral that is the answer to this one is, and by the way, when you actually write this for an answer, you can't use your y's. You got to remember what y3 is in terms of f and g. But you can use f and g. You don't have to write out all that fractional garbage.
That's good.
You don't have to do that, but you do have to reference the way they are referenced in the problem, which is f and g. And so we will go the integral from 0 to 6.8 again of f of g, no, g of x minus f of x, that's this part, 2 pi times x plus 1 dx. That's for full credit on that one. Do not use y's here. Use it the way it's referenced in the problem.
That would be embarrassing.
That would be embarrassing. I think it's really interesting that the D part is only worth 2, whereas the A part is worth 4. That seems backwards to me. This seems hard to
Do it
put
out
together.
by hand.
The nice thing is that since D is worth 2, if you screw this up, it won't cost you much. That's the good part about that. It just seems backwards to me.
Like someone else.
All right, we good on number 8. There was almost, except for the very last problem, almost no calculus in it. If you know how to handle your calculator. Just, I beg you, be certain and go slow and read it and reread it, one little thing at a time with your fingers like this, and make sure you put in what you intend. Otherwise, it's going to screw the whole thing. Got it? You know what I'm saying? And this is ugly stuff, so enter it carefully and read it. Make sure you got it the way you want it. Okay. Number 9, 14 points. And this one's got 3 parts. Nope. I lied. I respect it. It's got 4 parts, 4, 4, 3, and 3. Okay, so here's our table. I'm gonna erase this and put the table of values up here so I can keep pointing to it. So give me a minute to set this up. Did everybody get the link I sent you yesterday?
Yeah.
And did anybody try it? Did it work?
It's not bad.
The link? I sent everybody in the class the link to the review
Yeah.
because I've got it unlisted. I just wondered if anybody actually clicked on it and so, and is it the right one?
Yeah, I think.
Okay, I hope so. Okay, all right, here we go. I'll send you this link as well, the remainder of this. Okay, let me put it up here. T R of T 0, 2, 5, 9, 10, 0,
Calvin seems so much easier.
Yeah, this is super slow.
Okay. Here's the data that's given and here's what it says. I just decided to give you something kind of gross to consider here. It's not that gross on the actual test. Raw sewage.
Why did we?
Raw sewage is pumped into a tank over a 10-hour period.
Is the test about raw sewage too?
That's what I said. I just wanted to make it,
Did you?
gross you out a little bit.
Yeah, why is it raw? Like, there's just like no treatment in it?
Oh,
Yeah,
I
things they
know.
haven't run it through a screen of any kind yet. Everything's showing whatever got flushed down, that's what's in it. All right, raw sewage is pumped into a tank. We're gonna assume that it is liquid, however.
Let's see that.
Maybe a sludgy liquid, but liquid.
Like,
All right. Raw sewage is pumped into a tank over a 10-hour period. At T equals 0, the volume of the sewage in the tank is 55 gallons already. Already got that much in there. Let R of T denote the rate. Get that straight in your head. Let R of T denote the rate in gallons per hour at which sewage is pumped into the tank at T hours. The table shows 5 rate measurements over the 10-hour period. So somebody just at 2 hours just said, okay, right now it's flowing in at 5.7. At 9 hours, they took another snapshot and said, okay, at 9 hours it's coming in at 6.3 for whatever reason. I don't know what. Okay? So that's what's going on there. It's the rate at which it is going into the tank. This is what we need to do with that information. A part says, using the table, estimate the derivative R prime of 7. Interpret the meaning of your answer using correct units. So we locate 7 because that's what we're R priming. We locate 7. It's somewhere between here and here. As a matter of fact, it's right smack in between here and here. So I want to find the very best estimate we can get is I want to find the slope. And so to do A part, this is the math behind it. I'll explain a little more if you'd like, but the math behind it is the change in Y's, 6.3 minus 5.1, over the change in X's, which is 9 minus 5. And that's the average. Well, that's the best we can do at estimating what the rate was at 7. So that's 1.2 over 4, which is it 4? 9 minus 5, yep. 0.3. What does that mean? Does that mean that fluid at hour 7, our best estimate, that raw sewage is joining the tank at only 0.3?
That's the rate of that's the rate of how fast the rate is changing.
It's the rate at which the rate is changing. Yes.
So how come you just do that just because 7 is like directly in between 5 and 9? Or like if it was 8, would you still do that?
Wherever the thing you're evaluating, this is R prime of 7. If that were R prime of 8, you would still use these guys?
So just anything in between.
And here, because with discrete information like this, discrete means countable information, not continuous information. The best we can do with what we have to work with is this. What this is saying is that on the graph of this, and I have no idea what the graph actually looks like, but if I go out 5 and up 5, and I go out 9 and up 6, there's 2 points on the graph of this because it's continuous flow, but I've only got a certain snapshot of a few of them. So if the graph is going like this at some point, then the slope between here and here, which is what R is, pretty darn close to the slope at 7. If I draw it on that curve, those have about the same slope. It's the best we can do.
Yeah.
If I go to 8, and it might be slightly off, maybe just a little bit like that, still, this is the best estimate we can come up with what we have to work with. See what I mean? Okay. And I think it says, in part A, it says, estimate the number of gallons of sewage pumped into the tank. No, that was it. I see. Using the table, estimate the derivative of R prime of 7. Interpret the meaning of your answer using correct units. What will be the units on this 0.3 number?
Gallons per hour squared.
That's right. Gallons per hour, that's the rate, but it's the rate at which it's changing every hour. So it's like saying gallons per hour. And if you invert and multiply, you get hour squared. See what I mean? Okay. And if it says to justify your answer or interpret your answer using correct units, it doesn't mean just interpret it by putting correct units on it. Interpret what this means. 0.3 is the rate at which R of t is changing. And the thing is, and you don't have to allude to this in your answer, but R is already a rate. It's a rate of flow into the tank. This is the rate at which that flow rate is changing. That's why it has hour squared on it. You can refer to acceleration on this if you want.
Yeah.
Because this is the velocity at which fluid is flowing in. You can call this acceleration if you like.
Can you just say the rate at which the rate is changing?
Yes, that's fine. Yep. Part B, estimate the number of gallons of sewage pumped into the tank over the 10-hour period using values in the table and a left Riemann sum with 4 subintervals. Show the calculations leading to your answer. So now this one's going to, because these are not incremented evenly, this will show if you really know what you're doing. We're talking about a Riemann sum, which is made up of rectangles. And what we're really trying to do is, with the information that we have, we are trying to find this, an accumulation of raw sewage over a 10-hour period of R of t. That's what we're really trying to do, but we have to use estimates because that's all we've got to work with. And so this is approximately equal to, if we use a left Riemann sum, it's equal to 3.2, because that's the left value, that's 3.2 right there. But how wide is the rectangle for which this is the left side? 2. Added 2. The left side of the next rectangle has a height of 5.7. But how wide is it? 3. The next one is 5.1, and how wide is it? And the last one is plus 6.0 times 1. I'm just gonna put the 1 in there to show the consistency. What?
6.3.
Oh, yeah. Left side. Left side. Can you all imagine these rectangles, or do I need to draw them for you so you can see it? Do you understand that these would all be the same, but we would be using these if it said right Riemann sum?
Yeah.
You okay with that?
Yeah.
Or not?
Yeah.
Okay, so then you grab your calculator and add those up. This is what you have to show. You have to write that down and then let your calculator do the grunt work, but you have to show what you would calculate at the left Riemann sum. 3.2 times 2, 0.7 times 3. Oops, I missed the 7. 0.7 times 3 plus 5.1 times 4 plus 6.3. And I get 50.2, is that right?
Yeah.
And what are the units on this?
Gallons.
Gallons. That's how many gallons have accumulated over this 10-hour period in that tank. Well, approximately, yes.
So if it was right Riemann sums, then would you do 3.2 and then from 2 to 5?
No, I would not use 3.2 at all. I would say 5.7 times 2, 5.1 times 3, 6.3 times 4, and 6.0 times 1. Because these are the heights, these are the right-hand sides of the rectangles. If you drew your rectangles with the right side and then over.
Okay.
You know what I mean?
Like if you use the left side, you don't take the one on the right. If you use the right side, you don't take the one on the left.
Okay? So that's B. C part. This is another one. I cannot imagine why he's got this worth even 3 points. This shouldn't even be worth 1, but it says, using part B, estimate the total gallons of sewage in the tank after the 10 hours. 50.2 from B plus 55 from the stem of the problem.
That's my favorite part of the
Yes, I know. Yeah.
I like that.
Yeah. 3 points right there, if you know what you're doing. You gotta find out how much it started with, and then add in what we approximated was added in over 10 hours. D part says, using part B, approximate the average fill rate over the 10-hour period.
You just take that.
You just did that.
50.2 divided by 10. 5.02, what's the unit? Gallons per hour. Again, no calculus, just averaging. Now, if you were to show it as calculus, this is what this really is, even though this is instinctive for averages. What it really is 1 over B minus A times the integral from 0 to 10 of, what did I call it? R. But that's your 10 right there. And this we've already decided is 50.2. So you don't have to show this to me if you don't want, though he wants you to. I mean, it would be great if you would include that. That shows you know how to find the average value using calculus. But you used calculus ideas all the way through here. So if you just get to there and you do that, it's fine with me. Just make sure you have the correct units. If you were going to show the calculus so that everything is correct, you would write this and then write equals 5.02. Either way is fine with me. Both of them are instinctive, it's fine. What?
Because it was over the 57. If you did it right, that was the whole amount.
You wouldn't take the one that was left, you would take the second one.
Can you do it like on the big part? If you do like, you have all your numbers times the stuff, if you switch up like what you're timesing by what, does it change your answer?
Oh, yeah.
So
If you do a right ream on some, it will be this width times 5.7, because that would be the right side if you drew your rectangles with the right side.
you can't do it like backwards. You can't go like 6 times 1 plus 6.3 times 4.
Sure, if you want. You want to start here and work backwards and leave this one off, that's the same
Oh
thing.
wait, that's the same.
That's the same. as
Yeah, it's the
left
same
side,
thing.
you just start
Okay,
from
that
So either way, yeah. Everybody okay on number 9? Okay, number 10, delta epsilon proof. I have rewritten this one so that it looks like what we want to do instead of the way he wants you to do it. He tries to lead you through it. It's weird. So we're not doing that. I rewrote it so that it's like the ones we practiced. You get the same thing. It's just that you don't get confused. Hopefully. Okay, so number 10 says, prove that this limit is what we know it to be using a delta epsilon proof. Use the precise definition to prove that the limit as x approaches 3 of x squared minus 3x plus 1 is 1. Which by direct substitution, I hope you can tell that it is 1, because look, you get 9 minus 9 plus 1. So that is the limit, right? You just have to prove it using delta epsilon. So if this is what we're trying to prove using a delta epsilon, then you need to kind of state how you use this by saying, in other words, or just say, i.e., find a delta that meets this situation. When this is true. We're saying find a delta so that this will be true if this is true for this size epsilon. Delta will be in terms of epsilon when we're done. So that's how you started out. You're trying to prove this limit using delta epsilon. It means to do this. And we start with this. We try to turn this into something involving this. That's the idea. So we start out by saying f of x minus 1. You don't actually have to write what I'm writing here. I'm just trying to explain fully. Is equal to x squared minus 3x plus 1 minus 1. That's f of x minus 1. I'm just working on this for a minute. I'll come back to these ideas as soon as I get done with the algebra here. That's going to be x squared minus 3x. That's going to be x times x minus 3. Yeah.
Yeah.
The factoring out of x, leaving the absolute values on everything. Everybody good with that? That was f of x minus 1. That's what it's turned into. And so now if I come over here, I say that the absolute value of x times x minus 3 less than epsilon here.
So less than or equal to?
Nope, less than, strictly less than. And we look at what we've got now and we say, well, that's really close to what I wish I had, except for that dang x. And so we do a little manipulating. We say x minus 3 epsilon over the absolute value of x. And right here is the trick that he doesn't want you to use. He wants you to do a whole bunch of other crap. We're just going to pull the trick because I've seen it in several calculus books. This is what you do. And you say at the limit, x equals 3. Is that right?
Yep.
Then you have this, 0 less than the absolute value of x minus 3 less than epsilon over 3, because the absolute value of 3 is 3. Therefore, choose delta equal to epsilon over 3, and you'll have met, if delta is equal to epsilon over 3, then this is true. What that means, folks, is that if you've got, this is along the x-axis. If you've got a distance from the x value right at this point, if you've got a distance that is only a third of the distance up here on the y, then the limit is proven. This would be the answer I would be looking for. This is the part you have to get correct. If that's all you give me, I won't give you credit, but that should lead to that correct answer. We okay? Okay, there you go. When do you want to take this mock final? There you go, Devin. We'll give you that when you're ready. Monday?
Yeah.
Okay.